Hello students, welcome back to our mathematics class on our channel Amir Sir YouTube channel from Divine School. Now today's subject is mathematics and for SSLC class 10 topic is same. The same topic is going on. In earlier videos also I discussed circles, basic concept of circle, then one theorem was explained. Now today I am going to explain one or two questions that are remaining in exercise number 4.1. And the question is, question number 3, a tangent PQ. PQ is a tangent to the circle, right? Tangent is line that touches the circle at one point. So this tangent PQ is touching the circle at P of a circle of radius 5 centimeters, and the radius of the circle is 5 centimeters. Is OQ radius? No, OQ is not radius. Why? Because OQ is distance from center to a point outside the circle, and we know that radius is distance from center to the circumference. So OP is radius. Right? So radius is 5 centimeter. Meets a line through the center O at a point Q, and the tangent is meeting the center at a point Q, center O and Q is a point on tangent, they are meeting, so that in such a way that OQ is 12 centimeters and the length OQ is also given. OQ length is given, and that is 12 centimeter. OQ is 12 centimeter. Length PQ is PQ length is what? We have to find, and it's a multiple choice question. Answers are given, 4 options are given. Option A 12 centimeter, option B 13 centimeter, option C 8.5 centimeter, and option D under root 119 centimeter. So PQ, which is the correct answer? A, B, C or D? That we have to find. So we have to find the length PQ and say which is the right answer. And answer will be definitely one of these 4 answers given in the question, right? Okay, let's find. We all know in previous video we discussed, I explained a theorem on circles that angle between radius and tangent at the point of contact will always be equal to 90 degrees. Right angle, radius and tangent at the point of contact are perpendicular to each other. So here OPQ, according to the theorem, P is point of contact and OP is radius, PQ is tangent. So the angle between radius OP and tangent PQ at point P, point of contact, must be definitely 90 degrees. Must be a right angle, right? This is 90 degrees according to the theorem, right? Now if this is 90 degree, then triangle OPQ becomes a right triangle. OPQ is a right triangle, and we all know that in a right triangle Pythagoras theorem can be applied. We can apply Pythagoras theorem. In my earlier videos I have already explained Pythagoras theorem, its proof, and we also solved some questions, right? Now OPQ is right triangle, so we can apply Pythagoras theorem. Now we all know that according to Pythagoras theorem, in a right triangle means one angle must be 90 degree, and we have at P. In a right triangle, square on the hypotenuse is equal to sum of squares on the other two sides or other two legs, right? Now, which is the hypotenuse here? We all know that side opposite to 90 degree will always be hypotenuse. So if 90 degree is here at P, then side opposite to this OQ is hypotenuse, right? So square on the hypotenuse, OQ is hypotenuse here. Square on the hypotenuse is equal to sum of squares on the other two sides. Which are the other two sides? OQ, x except OQ, which are the other two sides, OP and PQ, right? So OP square and PQ square. We can say that right here, OQ square is equal to OP square plus PQ square. How did we get this? According to Pythagoras theorem. According to Pythagoras theorem, right? Now, substitute the values. Three sides are there. It's an equation. Three quantities are given. Out of three, two we know. We know OP, that is 5. We know OQ, that is 12. Third we can easily find, right? OQ is 12. 12 square. OQ is 12 and it has a square. Will be equal to OP. OP is 5. Radius is 5. 5 square plus PQ. PQ we have to find. PQ as it is. PQ and it also has a square. PQ square. Now solve. This is a linear equation, right? We know that 12 square is 144 is equal to 5 square is 25 plus PQ square. To solve this we have to make PQ alone. To make PQ alone, take 25 here. It will become 144 minus 25. That will be equal to, if you transfer 25 here, it's positive, it will become negative. Then PQ square. Therefore, PQ square is equal to, what is 144 minus 25? 14 minus 5 is 9. Here 3 minus 2 is 1 and 1. PQ square is 119. Remove square. We want PQ, not PQ square. So if you remove square, the other quantity on the other side will definitely go under the square root. It is same as taking square root on both sides, and this square root will get cancelled and this will come under the square root, right? So PQ is equal to 1 square root of 119 centimeter. Is 119 a perfect square? Is 119 a perfect square? No, 119 is not a perfect square, so no need to find its square root. We can find, but a decimal number will come, but no need, because in our answers, in our options, square root of 119 is already given, that is option D. So D is the right answer. D is the correct option. This way we solve, right? This type of question may come in exam, so do practice it. And since it is a multiple choice question, so you have to be quick in solving. It took a long time for me to explain, but you have to be quick in exam because it will be a 1-mark question. You have to quickly substitute the values and quickly get the answer and solve it within a minute or 1.5 minutes, because it will be a 1-mark question in exam. Hope you all understood the question. Let's discuss another problem. Yes, this is the next question. Our next question is, question number 4. Draw a circle. We have already drawn a circle. You can use a compass, which is in your compass box. You can use compass and draw the circle, right? Draw the circle. We have already drawn. And two lines. We have to draw two lines parallel to a given line, and those two lines must be parallel to a given line. That given line is already here, AB. Given line is already there. AB is the given line, which is a chord to the circle, right? It's not passing through center, and it is not necessary. It may pass through center, or it may not pass through center. That is not mentioned in the question. Just they are saying a given line. So I have already drawn AB is the given line, such that we have to draw two lines parallel to given line. AB is given line, such that one is tangent. Out of those two lines which we have to draw, one must be the tangent and the other is secant to the circle. We know already that tangent is a line that touches the circle at one point, and secant is the line that touches the circle at two different points. Secant touches the circle, cuts the circle at two different points. tangent touches the circle at only one point, cuts the circle at one point. Now first let's draw secant, and the condition is that it must be a secant and it must be parallel to AB. Right? Now imagine, suppose that line secant passes through this point. We'll draw a secant, so it will be like this. It will go like this. But to draw parallel line, there are some conditions, there are some rules. We cannot just directly put the scale and put the ruler and use the ruler and draw a line that may be parallel or that may not be parallel to the given line. But if we follow the proper method of drawing parallel lines, we can do that, right? And we all know that the method to draw line parallel to a given line is, take the point, suppose that parallel line secant is passing through this point, then join this point with the line, given line, right? Okay. And then take your compass and draw an angle here, draw an angle here, draw an angle here. An angle is drawn. An angle is drawn, right? Okay, then through this point also draw an angle. An angle is drawn through this point also, right? Okay. Now take this distance. Take this distance. This distance. Distance between this point and this point. This distance, fix this distance, it is already there. Then keep this here and cut this line. Sorry, keep it here. This line is drawn already. Then keep this one here and cut this. Right? We have a arc here and we have a point here. If you join this point and this point, that line will definitely be parallel to this line. Right? Okay. So we do it. Join these two lines, these 2 points. And let it pass through and let this line pass through this point, right? So these 2 lines are parallel to each other. These 2 lines are parallel to each other. Or do one thing, extend this line. In fact, extend this line. So you will see this angle will be equal to this angle. They are corresponding angles, right? These 2 lines are parallel to each other. This line and this line are. Now this is a secant, right? In the same way, we have to draw a tangent. Tangent must pass through a point that just touches the circle. Let's say the point is here. Now the procedure is join the line and this line. Right? Okay. Then draw an angle here. Now we have to draw line parallel to this line and must pass through this point. Right? First draw an angle here. Draw an angle here. And with the same distance, draw an angle here. Draw an angle here. Okay. And then take this distance, it is already there, and from here or from somewhere here, cut this. From here, cut this line. Cut this. We are getting from here, cut this one. We'll get a point here. Right? Now, join these 2 points. Draw a line passing through these 2 points. This line is parallel to this line and is tangent to the circle. Right? I show you the way to draw line parallel to. This is the given line, imagine. And the point is here. This point I took inside the circle here first to draw the secant, and the same point I took here on the circle so that the line will be tangent to the circle. Right? What you have to do is first join these two, the line and the point. Draw an angle here, and with the same distance draw an angle here, draw an arc here, and then take this distance from this point to this point, fix it in your compass, right? And with the same distance you have to keep the compass here and draw an arc here, and that will give you a point. You join these 2 points, this point and this point. Joining these 2 points, you have to draw the line. This line will definitely be parallel to this line, and these 2 angles will be equal. They will be corresponding angles, and this is the transversal, right? So here is the secant. We have a secant here, we have a tangent here, and these 2, secant and tangent, are parallel to this given line AB. Is this point clear? I hope you all understood this. We'll discuss another theorem in my next video. Hope you all understood. Like the video, comment, subscribe our channel. If you have any doubt, you can write in comments. Thank you.